It's 5:15 in the morning, and a storm is rolling over the Gulf of Mexico. Lightning cracks over Cumalub-Zop, Mexico's most important offshore oil field. Somewhere below the churning water, a pipeline 12 inches wide gives way. Gas that has been trapped under pressure for millions of years starts rising toward the surface, and when it breaks through, the ocean does something it should never be able to do. It catches fire. Not a patch, not a flicker, but a perfect glowing ring of orange flame sitting right on top of the water, like something drawn onto the sea with a compass. Fireboats circle it and spray water directly into the blaze, and nothing happens. Because water isn't the fuel here. The fuel is coming from underneath. For 5 hours, the eye of fire burns, until engineers finally choke the valves below and pump nitrogen into the water to smother it from beneath. People call it a freak accident, but it's actually a window into something much bigger. That fire came from a world that sits under the seafloor across the entire planet. A world built out of methane and heavy ancient hydrocarbons squeezed under enormous pressure for millions of years. Every so often, that world breaks through. Sometimes it burns, sometimes it erupts as something you'd expect to see on land, not 3 kilometers underwater, and sometimes it feeds things that are alive. Let's start with the eruption. In 2003, scientists are mapping the seafloor of the southern Gulf of Mexico at a depth of 3,200 meters, cold, crushed by pressure, and completely without light. They're expecting the usual, a cold seep, some bubbling gas, maybe a briny pool. Instead, their cameras find something that looks like a volcanic island, except it isn't rock and it isn't lava, it's tar. Thick, heavy petroleum is oozing straight out of the earth, and it's slightly denser than seawater, so instead of rising, it spreads, folding into ropey black flows that look exactly like the Pahohu lava fields of Hawaii. Some of it does something even stranger. Because the tar is slightly buoyant before it cools, it extrudes upward in long vertical plugs, thin black whips that hang in the water, still anchored to the seafloor until they lose their buoyancy and slump over into strange frozen sculptures. Researchers name the site Chapapote, Spanish for tar. And here's the part that shouldn't make sense. This slow-motion asphalt volcano, made of one of the most explosive substances on the planet, isn't a wasteland. It's a reef. Squat lobsters crawl across the hardened tar. Alvinicaris shrimp swarm the flows in dense clouds. Life didn't avoid the eruption. It moved in. And if an erupting tar pit can host a colony of shrimp, you have to wonder what's living somewhere even more hostile than that. Which brings us to 1997. Charles Fisher, a biology professor from Penn State, is 540 meters down in the Johnson Sea Link submersible, doing what should be a routine job, collecting tubeworms near a known hydrocarbon seep. At the time, methane hydrate, sometimes called flammable ice, is considered geologically interesting, but biologically dead. It's just frozen gas trapped inside a lattice of water molecules under crushing pressure, like a microscopic prison holding an explosive inmate. Nothing is supposed to live on it. Then, the submarine's lights sweep across a mound of yellowish-white ice, more than 2 meters wide, sitting exposed on the seafloor, and the surface of the ice is moving. Thousands of small, flat, bright pink worms are crawling across it, each one only about as long as a paperclip. Fisher has just discovered an entirely new species, Cerso methanicola, the methane iceworm, the only known animal on Earth that lives directly on gas hydrate. They dig shallow divots into the frozen methane and waft oxygen-rich water over the surface, farming a bacterial garden that grows on the melting edges of their burrows. It's the equivalent of earthworms burrowing into the side of a lit stick of dynamite, and using the heat to grow a vegetable patch. Not everything down here builds its home on top of the danger, though. Some things live right beside something even worse. At the bottom of the Gulf sits something scientists nicknamed the Jacuzzi of Despair, a lake underneath the ocean. Buried Jurassic salt deposits dissolve into the seeping fluids here, and the result is water so dense with salt that it pools on the seafloor instead of mixing upward. It has its own shoreline, its own surface, with ripples like a lake sitting inside a much bigger lake. Any fish or crab that swims down into it suffocates almost instantly, and gets perfectly preserved in the brine, an eerie, silent graveyard frozen mid-motion at the bottom of the sea. And yet, right at its edge, tubeworms over 3 meters long, some more than 400 years old, grow calmly in water just a few degrees above freezing, feeding on the same toxic chemistry that kills anything that swims too deep into the pool beside them. A burning ocean, a volcano made of asphalt, worms farming dynamite. A lake that mummifies anything that touches it. None of this should exist, and yet all of it is only the visible edge of something quietly holding the whole system together. In the sediment around every one of these seeps, two microscopic organisms are working together. An archaeon and a bacterium, physically wired to each other by microscopic nanowires, trading electricity in total darkness. Together, they filter out more than 90% of the methane trying to escape from the seafloor before it ever reaches the atmosphere. Methane is over 80 times more potent than carbon dioxide as a greenhouse gas, which means these strange sunless ecosystems aren't just surviving down there. They're standing quietly between us and a much hotter planet, and that balance is not as far from us as it sounds. In 2010, the Deepwater Horizon blowout sent almost 5 million barrels of oil into this same gulf, along with a massive surge of methane gas. Now nations are looking at flammable ice itself as a future energy source, something to drill and mine directly from the seafloor. Which means the very reserves these ecosystems have spent thousands of years learning to live on top of could soon be disturbed on purpose. And if life can run entirely on toxic chemistry in the cold and the dark, without a single ray of sunlight, then maybe the icy hydrocarbon-soaked oceans hiding under the surface of Titan or Europa aren't as empty as they look. So, if a whole ecosystem can hide in plain sight, quietly keeping something much bigger in balance, what else right now might be holding a line we've never even noticed?